So let's say you're taking a quiz in your physics class and you have to solve a projectile motion problem. Here's one method. Statement: a tall physics genius, that's you of course, throws a golf ball 30 meters per second, 60 degrees above the horizontal. If it falls 40 meters vertically below the throwing point, find where it lands. The find where it lands, of course, is all about the horizontal displacement. You're given the vertical displacement as 40 meters and the horizontal is the unknown. And the ball is thrown at 30 meters per second, 60 degrees above the horizontal. That is closer to the vertical than the horizontal, so the vertical component should be larger than the horizontal component. That statement in black, that's the problem. Everything else is done by you, the problem solver. So the first thing you do is get a good sketch, and that sketch looks something like what you see there. 60 degrees above the horizontal, the 30 meters per second shows the initial velocity, then the parabolic trajectory, and it should land at the horizontal displacement d sub x, that distance horizontally away from the launch point. 40 meters vertically, and the initial velocity at 30 meters per second. It is at an angle of 60 degrees from the horizontal, and it's 30 degrees from the vertical. Therefore, that 30 meters per second does not belong to either the horizontal or the vertical information columns. So you have to split it. On the right hand side, the 30 meters per second is split into the two vector components, or resolved into its two components. That's a 30, 60, 90 triangle, so the ratio of the hypotenuse to the short leg is 2 to 1. So you take 30 meters per second divided by 2 to give you 15 meters per second. And then take the short leg multiplied by the square root of 3 to get the long leg, which is 26 meters per second. You could also take 30 meters per second times the cosine of 60 degrees to get 15 meters per second, and then 30 meters per second sine 30 degrees, 60 degrees, sorry, 30 meters per second sine 60 degrees to get you 26 meters per second. Then all that information goes into the chart directly below. Organize all your information. This is the center of your problem. That chart is the center of the entire problem solution, so keep it central. Keep everything horizontal on the left hand side, everything vertical on the right hand side. The horizontal component of velocity is 15 meters per second. That's constant and goes on the left hand side. Vx is 15 meters per second. The acceleration on the left hand side is 0 always. That's why the horizontal component is 15 meters per second. And that's why it's Vx and not Vix and Vfx, because all the V's on the x side are constant. Right hand side, the acceleration of gravity is negative 10 meters per second squared. The displacement in the y direction is negative 40 meters. It falls 40 meters. So starts high, ends low, has to be negative. Initial velocity in the y direction, it is up. It's fired above the horizontal, so it is 26 meters per second. That value is positive. And you want to find the displacement, so you try working on the left hand side. dx is equal to vx times t. That's a variation of the first equation that you know. Average velocity is displacement over time. And then, so d is equal to v times t, 15 meters per second, but you don't know the time yet, so you have to go to the right hand side. Best way to find time, easiest way, is using the equation. The displacement is equal to the initial velocity times time plus the 1/2 the acceleration times time squared. Plugging the values in for the y side on the right side, negative 40 meters is 26 meters per second times t plus 1/2 times negative 10 meters per second squared times time squared. Be careful of the negatives, you will tend to drop them. Be careful of the squares, you'll tend to drop those also. Organizing that so you can solve it like a math problem and dropping all the units so it looks a little cleaner. Putting it in the ax squared plus bx plus c order that you're used to for your math class. Negative 5t squared plus 26t plus 40. Add 40 to both sides to get that plus 40. Then if you take your calculator and graph that, because that's the easiest way, take it, graph it, find the zeros, and the zero that you want that is the only positive one, and that'd be 6.44 seconds. Take that 6.44 seconds, transfer it to the left, and multiply 6.44 times 15 meters per second to get 96.6 meters. And that's it. That's all you have to do. But remember, keep everything separate. The horizontal must stay in the horizontal column, vertical must stay in the vertical column.